Gravity or gravitation is a natural phenomenon by which all things with mass or energy, including planets, stars, galaxies, and even light, are brought toward one another. On Earth, gravity gives way to physical objects, and the Moon's gravity causes the ocean tides. The gravitational attraction of the original gaseous matter present in the universe caused it to begin coalescing, forming stars, and for the stars to group together into galaxies. So, gravity is most accurately described by the general theory of relativity, which describes gravity not as a force, but as a consequence of the curvature of spacetime caused by the uneven distribution of mass. The most extreme example of this curvature of spacetime is a black hole, from which nothing, not even light, can escape once past the black hole's even horizon. However, for most applications, gravity is well approximated by Newton's law of universal gravity, which describes gravity as a force which causes any two bodies to be attracted to each other, with the force proportional to the product of their masses and universally proportional to the square of distance between the earliest instance of gravity in the universe, possibly in the form of quantum gravity, supergravity, or a gravitational singularity, along with ordinary space and time, developed during the Planck epoch, possibly from a primeval stage, such as a false vacuum, quantum vacuum, or virtual particle in a currently unknown manner. Attempt to develop a theory of gravity consistent with quantum mechanics, a quantum gravity theory, which all allow gravity to be united in a common mathematical framework, with the three forces or pieces are a current area of research. In 1687, English mathematician Sir Isaac Newton published Principia, which hypothesized the inverse square law of universal gravitation. In his own words, I deduce that the force which keep the planet in their of mass reciprocally as the square of their distance from the center about which they revolve, and the rabbi compared the force request to keep the moon in her orbit with the force or gravity at the surface of the earth, and found them answer pretty nearly. Newton's theory enjoyed its greatest success when it was used to predict the ancient stance of Neptune based on motion of Uranus that could not be accounted for by the action of the other planet. Calculation by both George Coach Adam, and urbanly very predicts the general position of the planet, and the fair calculations are what less Johann Gottfried Gale to the discovery of Neptune. A discrepancy in Mercury orbit pointed out flaw in Newton's theory. By the end of the 19th century, it was known that its orbit showed slight perturbation that could not be accounted for entirely under Newton's theory, but also shares for another perturbing body, such as a planet orbiting the Sun even closer than Mercury, had been fruitless. The, the issue was resolved in 1917 by Albert Einstein. New theory of general relativity, which accounted for the small discrepancy in Mercury orbit. Example number 1. When we throw the ball will come back to us. Number 2. When we jump, we will fall down or to earth because of gravity. Number 3. If the moon stops revolving around the earth, the mass of the earth will pull the moon to the earth. Number 4. If the sun were smaller in mass, then the earth would slingshot out of its orbit and go hurtling into space. Number 5. A baby will crawl out of its nest and gravity from the earth pull it to the ground. The benefit of gravity. Number 1. Maintain the stability of life and earth. Number 2. Make everything on earth in its place. Number 3. Make everything have. Number 4. As a source of knowledge development. Number 5. Keep the moon and satellites in orbit.